Now we need to discuss bearing capacity of the soil. What is bearing capacity? It is known that the load of any structure is finally transmitted to the soil lying below the foundation of the structure. Hence, it is very essential to know the strength and behavior of the underlying soil. Bearing capacity of the soil is its ability to support the load coming over its unit area without causing excessive settlement and displacement. The minimum load on unit area causing failure is called the ultimate bearing power or ultimate bearing capacity of the soil. Actually, load allowed on the soil is much less than its ultimate bearing capacity. The safe bearing capacity of the soil can be found out by dividing the ultimate bearing capacity of the soil by a factor of safety. The value of factor of safety usually varies from 2 to 3 depending upon the nature of soil. Bearing capacity of the soil depends largely upon the characteristics of its particle. Finer particle soil exhibit less bearing power than those having heavy and coarser particles. Soil having finer particles are affected much more than those having coarser particles due to change in moisture condition. Maximum safe bearing capacity of the soil and allowable bearing pressure on soil are mostly understood as meaning the same thing. The two terms are actually different. The bearing capacity of the soil is used to indicate the maximum pressure to which a soil can be subjected to without causing any shear failure of the soil. In this case, settlement of the soil is not considered. The allowable bearing pressure on soil is used to indicate the maximum pressure to which soil can be subjected to without causing shear failure and excessive settlement of the soil. Generally, the value of maximum safe bearing capacity of the soil is more than the allowable bearing pressure on the soil. Maximum safe bearing capacity of the various soil may be are different types. Okay, the details of maximum safe bearing capacity are given in the chart. You can take a screenshot, okay, in that slide. Okay, next, now we go for describe the method of determining the bearing capacity of soil. There are two method of determining bearing capacity of soil. One is dropping weight method and another is method of slowly applying load. Dropping weight method: in this method a known weight is dropped from a height on the bottom surface of the foundation trench and depth of the impression made on the soil is noted. Okay, bearing capacity soil found according to this formula. Okay, that are where the terms are given. Here the notations are R, H, D, A and W. What is R? R is ultimate resistance offered by the soil. H, height from the trench bottom from where weight is dropped. D is the depth of impression made by the falling weight. A is the cross sectional area of the falling weight coming in contact with the soil. W is the weight of the falling weight. Now, energy lost in penetration is equal to the potential energy of the falling height. So, W is multiplied with H is equal to R into D. So, R is WH by D. Ultimate resistance of the soil or unit area is R by A. If F is the factor of safety, the safe bearing capacity of the soil per unit area is equal to R by A into F. This method of evaluating the safe bearing capacity of the soil is the approximate method and hence should be used in case of minor structure only or where method of slowly applying load is impracticable. Okay, impracticable. Method of slowly applying load: this method of evaluating the bearing capacity of the soil is the most reliable method. It consists of an arrangement with the help of which specific area of the foundation soil is gradually loaded in step by increasing load in phase and corresponding settlements of the foundation noted. The loading of the foundation is continued with continuously increasing load till foundation soil starts yielding. So the arrangement for Loading the soil consists of a wooden block 300 mm into 300 mm in cross section and 1.25 meter to 2.5 meter long. Length of the block is depend upon the depth of the foundation trench. A flat iron plate of 300 mm into 300 mm and about 18 centimeter thick is attached at the bottom of the block with the help of countersunk screw. The pit in which loading test is to be carried out should have its planned dimensions at least 5 times the corresponding side of the steel plate. Since mostly 300 mm into 300 mm steel plates is used below the block for loading purpose of the soil, the size of the pit should be at least 1.5 meter into 1.5 meter. Depth of the pit should correspond to the depth of the foundation. Now 300 mm into 300 mm area at the center of the pit is made level by scraping the surface, and timber block attached with 300 mm into 300 mm steel plate, also known as sole plate, is erected vertically over it. A loading platform is constructed on the block. Four inclined struts are used to maintain block in vertical position when platform is being loaded. Top end of the inclined struts are attached to sliding feet collar fitted near the top end of the block and prevented from sliding by a system of horizontal struts provided at their base. Two wooden pegs are driven at the bed of the pit a little away from the sole plate. An exact level difference between top of the peg and the top of the loading platform is recorded. The weight of sole plate, wooden block and other framework are carefully worked out to know the exact weight to the framework. Test load, which normally consists of sandbags rolled steel section, is then slowly put on the loading platform. The amount of load to be put on the loading platform initially is decided according to the type of soil under test. A level instrument is set a little away from the loading platform to note the settlement of the steel plate and loading platform under load. The load initially applied is kept constant till the settlement of the ground under sole plate stops. Now the load on the platform is increased by suitable amount, usually 500 kg, and again maintained constant till settlement of the ground again ceases. Again, load on the platform is increased and allowed to stand till settlement of the ground again cease. This process of step by step loading of the platform is continued and settlement noted till a stage is reached. I will give a chart where we will conduct a settlement, conduct the test with date and timing, taking readings. Okay, I will take it from a specimen. You will understand by watching the chart. Okay, here we will understand the slowly applying load to know the bearing capacity. And the process of verify the given bearing capacity of soil. Sometimes a bearing capacity is given. Now need to just understand that is okay or not. To verify this, the method of slowly applying load can be used. Okay, for verify this, let given if the say bearing capacity of soil is say 16 ton per meter square. For verification of bearing capacity of this soil, apply an initial test load on the platform twice the safe given bearing capacity, that is 32, cos 16 ton per meter square is given 32 ton per meter square, and note down the settlement. When settlement ceased, the load on the platform is increased by 50%, that is 16 ton per meter square, and the settlement is again noted. In both the cases of loading, if the settlement does not exceed 17 mm to 25 mm respectively, the given say bearing capacity of the soil is correct. Okay, so next chapter we will go further is method of improving bearing capacity of the soil. How will improve the bearing capacity of soil? First is compacting of the soil. In this method, the width of the foundation trench is increased by 300 mm or so, and 300 mm or so, and then a layer of rubble is spread in a thickness of about 300 mm to 400 mm over the bottom of the foundation and rammed. If rubber gets completely buried into the soil, another layer of rubble about 150 mm to 250 mm is spread and rammed. The foundations treated in this way show considerable improvement in their bearing capacity. Next is increasing depth of the foundation. Bearing capacity of the soil get increased by increasing the depth of foundation, but this measure can only be adopted at sites where subsoil water table is very much below the foundation. Now we are going to discuss about the types of shallow foundation. There are different type of shallow foundation. Between them, first is spread footing, 2 grillage foundation, 3 eccentrically loaded footing, 4 combined footing, and 5th is mat or raft foundation. According to that, under spread footing there are different type of footing are there. One is wall footing, 2 reinforced cement concrete footing or RCC footing, and third is inverted arch footing. What is wall footing? In this type of foundation, course of brick below the superstructure wall are laid by giving 50 mm outward offset on either side of the wall. The depth of each course is normally 100 mm. However, in some cases, thickness of the masonry may be two courses of 100 mm each in each step of the footing. Okay. The concrete bed performs many of the following things. In case of wall footing, they are: it provides plain surface upon which footing masonry can be directly started. It rectifies the inequalities of excavation. It bridges over the soft patches in the soil below. It distributes transmitted load on large area. Concrete bed layer is kept 100 mm to 150 mm projecting beyond the bottommost course of the footing. Okay, brick masonry for footing of the brick wall is taken very much important. Okay, width of the footing when footing are provided is 2t plus j, where j is the projection of the concrete bed block behind the bottommost brick course of the footing. Like these things is to be maintained. Next is reinforced cement concrete footing. If a masonry wall is subjected to a very heavy load and bearing capacity of the soil on which footing is raised very low, that time reinforcement cement concrete footing may be provided. Okay, this completely eliminates the use of bed concrete in the foundation and proves economical than massive masonry footing. Generally 8 centimeter thick layer of lean cement concrete is provided before reinforcement concrete footing is constructed. Next and last is inverted arch footing. This type of foundation is normally not used these days in buildings. However, it may be useful in structure like bridge, reservoir, supports for drainage lines, etc. In this foundation, contact area of the foundation is quite large, and as such intensity of pressure on the soil is very much reduced. Now we'll go into discuss grillage foundation. There are different type of grillage foundation. The main are two types. Okay, steel grillage foundation and timber grillage foundation. What is a steel grillage foundation? This foundation consists of one or two tiers of RSJ embedded in the cement concrete. RSJs used in this foundation are also known as grillage beam. In this foundation, the depth is limited to 1 meter to 1.5 meter and width is increased considerably to bring the pressure on the soil within permissible limit. Normally, this foundation is constructed by providing RSJ or grillage beam in two tiers. Direction of grillage beams of one tier is perpendicular to the grillage beam of the second tier. However, in case of wall carrying not very heavy load, grillage foundation may consist of only one tier of RSJs. The load carried by the steel stanchion or wall is first transmitted to the upper tier of the beams, then to the second tier lying below the upper one, and finally to the soil below the foundation. Okay. Next is timber grillage foundation. Timber grillage foundation using timber planks and timber beams can also be used to support heavy loads on poor soil, but such a foundation should be adopted under the circumstances when soil where it is to be constructed always remain waterlogged. In this foundation, no concrete block is used, but instead timber platform is used. Timber platform consists of 50 mm to 75 mm thick planks placed touching each other. Above this platform, lower tier of scantling nearly of 80 mm into 120 mm size is placed, covering full length and breadth of the rectangular platform. Lastly, a heavy log is used at the center of the scantling of lower tier and timber column is centrally placed over it. The load from the timber column is transferred to the lower tier of scantling through heavy log placed directly below the column. Then students, welcome. I think you all enjoying by watching the session of the chapter foundation. If you like it, then kindly subscribe the channel, and we will come soon with another chapter with detailed specification. Thank you.